with Japan. Let's step in.
Again, very much for the opportunity, and both myself and Asim are very grateful and honored to be here. So anyway, what I'm going to do is, with Kernel, I'm going to talk more specifically about the trustworthy AI side of things rather than the core blockchain side of things, but then how both of them tie together. So I think just to give context, just who is Kernel? So basically, myself and Asim are the co-founders. We met in November 2022, where Asim was on stage as a speaker at a very high-level event in Dubai, talking as a panel with other investors about investment. And when he walked down, I basically spoke with him and said, you know, I'm very interested, I have a project I'm working on, would you give me some advice? And it just happened that I live in Manchester in the UK at the time, and Asim only lives 30 miles away from me in the UK, so we really had a chance to get together a lot. So Asim will talk about his background, but mine I'll cover a little bit more in the next slide. But we're very fortunate that as part of our team, and I think a lot of it's got to do with Asim's contacts and my contacts, we have some amazing advisors. So Naveed, he's, again, just like me, I've been in the industry a very, very long time. 4 decades is an incredibly long time. But Naveed is the co-inventor of WebAssembly. So if you use that in technology these days, you won't know what that is, but he's a co-inventor and he's a great advisor on our platform. And then we have Jennifer, she's a PhD in data science and AI. I think she's the first black lady out of one of the main universities. I forgot the name of the university in the USA. She's based in Washington, DC, so she has a lot of contact with the legislation in that area. And finally, we have a chap called Pras. He's one of the top cybersecurity people in the world. He's at the moment actively working with the national grid between the UK and the USA. So you can imagine whatever technology you build, when you have these advisors helping you, you always know you've got somebody you can go to if you're not sure about something. Okay? So my background, and forgive me, I don't wish to sound like I'm always talking about myself, but I just think it's easier for people to understand who and what experience somebody brings to, you know, what you're here for. So I started really my career, I started writing code in 1979. Machine code and assembler. So I'm not sure if anybody is anybody older than me? I turned 60 in January. Is anybody older than me? Any hands? Thank you very much. And I feel good now, only one person, but honored because it's the best person. Thank you. So in the mid-80s, I went to university in the UK and I went to do a degree in computing. But unlike theoretical degrees, I felt very much like the only way to test my ability was to go and do something. So I took 15 months out of university. We call it industrial placement. So out of the university to go work in a research institute. And even though I didn't know what I was getting myself into, I ended up working in 1985 and 86 in AI and doing sort of image and voice recognition in distributed parallel processing, all sort of very low-level work, working on Unix as an operating system and so forth. I was very lucky after I finished my course in 1989. I literally was approached by Microsoft and they asked me if I would work for them, and I became the lead for operating systems and programming languages. So I was employee number 7 in Europe. But I was actively obviously working very much with Redmond and the USA, and later on working with the sort of team in Windows 1. We helped bring Windows 1 to market in terms of the technology that was inside it. And more importantly, from my side, I was more actively involved with the SDK, because Windows to most people is just WYSIWYG, you know, window arrows, blah, blah, blah. But really, the SDK is what brings to life. It brings the applications. Okay, everything else is pretty much listed there, and you know, I think the only ones worth mentioning is just one little correction. I didn't work for BlackBerry. I gave them in 1993. I built a technology called push email, and the reason for that, everybody always asked me, why, how did you come up with the idea? So when I was working at Microsoft, near my end of my career before I resigned, I was asked by Bill to work on email, workgroup, and workflow. So I reported to Bill Gates, but the object was that I had to work on email because Microsoft believed email was going to be the killer app, the one app every person on the planet will use. So I took over that area, and in those early days, working with the team in Redmond, I helped create what's called Microsoft Exchange, the product that you may know of. But one thing I hated in those early days was I have a laptop. If I want to check my email, I have to plug it into a telephone line. I have to dial up, wait for it to dial. Sometimes it connects, sometimes it doesn't connect. And then finally when it connects, I find one, there's no email, so I'm wasting my time. And two, there are emails I'm not really interested. So again, I'm wasting my time. And it came to me that surely there must be a better way. So when I returned from the US, I was working in the US for 93 to 94. When I returned to the UK, I bought myself my first mobile phone. At that time, we were transitioning from analog technology to digital technology. And I remember I got the mobile phone, and the lady in the store said to me, it will only work in 24 hours when you receive a message on the phone. And I was like, okay, no problem. So I bought the phone, and I went home. Next day, a text message arrived on my phone. And I saved the text message, and my phone started working. And I was like, oh, that's interesting. So I contacted the telecommunications provider and said, where did this text message come from? And they said, oh, we have a short message service center which we use for billing. It activates the phone. And that's when I had the idea, right? If I can integrate email into the short message service center, then I can push the email whenever it arrives on a mail server to the short message service center, and that would send it as a text message to the mobile phone. And that is how push mail started. And then I contacted BlackBerry, or in that time they were called Research in Motion in Canada, and they were building two-way pages. And because the two-way pages were very compact, I only had 2 or 3 buttons. They were the best people I could think of to build what I had in mind, which was a mobile phone, with receiving emails, but where you can open Office applications. And so the idea of the QWERTY keyboard and using your thumbs, that was me, the phone and everything. So I gave that invention to them, and that created in 1993 the BlackBerry. The phone's name is BlackBerry, the company is Research in Motion. So I've given you that only because a lot of people ask me about that area, and I just think, but also I think the reason why I liked talking about that story, it shows how you invent and how you innovate, right? A lot of you in this room will go on to, whether it's your jobs or building some products or building a new company, where does it start? And I believe I was solving a problem. Okay, so the rest of it really is pretty clear. I worked very closely with Apple to create Apple Retail. I got involved with Web3 and blockchain in 2016. I did a proof of concept to do with healthcare, but in 2017-18, I was working with the UN on building a proof of concept for blockchain to do with the management of containers being shipped around the world, because the United Nations wanted to know. So I was an advisor a technology advisor to the United Nations at that time. Okay, so moving on, I think enough about me. Okay, let's start with the reason we're really here. So the EU sort of regulation really, I think is started or underpinned by GDPR. So I'm assuming everybody in the room understands GDPR. Yeah? Okay. So the GDPR is really, ultimately, it's about protecting you, right? That's what it's really about, because it's your data. So AI, if you think of AI right now, AI is not everywhere. It's a mandate. Almost every organization, every enterprise, every government has a mandate that AI must be used, and used in a controlled way, okay? You're maintaining, you as human beings, simple things like your dignity, simple things like you should know when you're using AI, your privacy. You know, all these things are really, really important when it comes down to it, right? So, because last thing is, you want to know who you're communicating with, and are you communicating with a trusted actor? So, the EU came up with sort of a regulation which was like, let's at least categorize the type of AI. Yeah. So if it's very, very, not very harmful, you can see in the triangle, no risk system activities. Okay, maybe we don't need so much control. We don't need so much auditing, traceability. But as you work up the triangle, you can say, I mean, how many of you would be happy to get into a Tesla or get into a Waymo taxi, which is autonomous, and feel that the taxi or the car is okay, it's not going to crash or kill you. Yeah, we just trust it. I don't know, in Korea, do you have autonomous AI vehicles? Yes, no? No.
It's just
Okay, so at the moment you're not at the top level. But imagine even more than that. Tomorrow you go to a hospital and a robot is going to do the operation. Yeah. Now, if the model that is driving it, the AI, imagine there's a back door or somebody's jailbroken it or done something. How do you know the model is behaving the way it was trained to behave? Yeah. So all of that is very simple. I mean, we drink water, we use AI, right? But you have to have those controls in place. So the whole idea behind all of this is that at the end of the day, we're creating these different levels. Now, like it says here, the EU Act binds the whole of the European Union together and sort of says we will act as one, which is what the EU is always about. But one thing that people don't recognize is that the EU Act is not just for EU people, but anybody working or doing anything with EU people has to comply with this regulation. So to me, it's the whole world, right? Because we are from the UK, but how many people do you meet from the European Union? Right, pretty much everyone. So we're seeing the proliferation of the EU regulation now being adopted, some form of it by almost I think 30 countries right now. Asim and I were last week in Bangkok, the week before we were in Abu Dhabi, and we were meeting with the CEO of the Blockchain Center in Abu Dhabi, had a meeting with Dimitri from ADG and the government to do with the UAE and the government, and they are looking to adopt not line for line the EU regulation, but looking to adopt the regulation in some form. Now, the question I ask here in the room is, where is Korea? And as the public, as a consumer, I would want my government to look after my rights, my privacy. These things are very, very important, right? So again, forgive me, I haven't reviewed a lot about the Korean side of where it's going, but I'd like to think when we're being invited by people like Alan and yourselves at the university, people like us here, people must be taking this seriously. Okay, so I'll just move on again. So the key components of the EU regulation is just broken down into articles and annexes at the end of the day. Now, what I've tried to do is, I know you can all read the EU regulation yourself, but I just want to give you a brief idea of the structure, but the key points, okay? Because you can read, you're all very literate, very educated people. So you have 113 articles arranged in 13 titles. And the annexes again, our EU has 13 annexes. So that's the format of the document. Okay. What does it have really inside it? Well, this is basically the parts which I think are the most relevant to do with AI. Okay, so if you look at this, and I'm not going to read through all of it, but risk management systems, data and data governance, technical documentation, that's just documentation, record keeping, human oversight. Okay, that's the one that I really want to talk about a lot. In the EU regulation, having human in the loop or on the loop is considered the key part. Okay, so if you are really involved, and I say that because I'm not sure how many people have watched the Terminator movie with Skynet, and it takes over the world and it kills all the humans. The ultimate part is you need to have some oversight or even a kill switch. Okay, so the whole idea being is today I'm not sure how many of you are following everything certainly to the depth I follow, but today we have a lot of autonomous agents or agentic system with AI agents. And there are more AI agents speaking and communicating with each other through MCP, the Model Context Protocol, or A2A, Agent-to-Agent Protocol on Google, to each other than there are human beings on the planet now, today. So AI is talking to each other more than we are talking to each other. Right? So, and people are sort of saying, oh, AI is creating its own language so it can hide what it's doing from us. Yeah, and the funny part is, I remember the first time I met Asim, and we were in Dubai in 2023 when we were in Dubai. It's when we got our first check, our pre-seed, and Asim will talk more about kernels and our funding. One of the guys was an AI expert as a venture capitalist, and he asked me and he said, what do you see as the future in the world? And I remember in December 2023, I said to him, AI will have its own language. And he said, why do you say that? And I said, whichever language we have today linguistically, it's very poor and inefficient. So why would AI agents talk our language? Right? Technology works with zeros and ones. Maybe they just need to talk in zeros and ones. But then if you take it beyond that, and again, I'm not sure how familiar you are with quantum computing, but with quantum entanglement, we don't even know how one change immediately happens, could be galaxies and light years away somewhere else. So the bottom line is AI will have its own language. It will operate in its own way. I believe, and this is purely my belief, and let's see, I believe within 2030, AI will create its own processors, not even NVIDIA. NVIDIA's engineers today, the silicon that they produce, might today be, human created and designed. But I believe within the next 5 years, AI will come up with the AI silicon, which is best for it. So just like we on the planet try to have the Earth be good to us, sustainable, we want to get value from it, the AI will say, look, what you're doing in silicon is not efficient for me. Okay? So if you're in the world of engineering, all of this area, expect you to just be somebody who wants oversight and control, because AI will just do its own thing. Okay, one other thing I want to do is, I know I can talk a lot about the EU Act, but I think for this forum, it's worth mentioning there are other frameworks and regulations. The ISO 42001, it's a global, as I said, framework, and it again has a lot of information about AI and how you should deal with AI. So if you think of it here, right, governing AI systems responsibly, managing risks and opportunities, and so forth. And again, it's made up of its clauses and annexes, but I would encourage you all that, to have a look at the ISO 42001. But what I want to do is just make you aware of it, because I believe it sets the global de facto standard. So whereas the EU regulation is very centric, to the EU, the ISO 42001 really is being adopted at a global level. Okay, so that's the one, and it doesn't mandate things like in the EU regulation, if you don't obey the rules of the law, you can be fined up to 35 million euros or 7% of your global turnover. Those are those steps where it's very strict about you complying. The ISO regulation is just a guide, just a framework, right? But at the end of the day. Now, to give you another one as an example, and again, I'm going to move through this and I'll keep talking about it. So you have the NIST framework in America, which is, the National Institute of Science and Technology, and, to do with what their recommendations are to do with AI. So there are many bodies who are beginning to understand. And believe me, I think the EU has had a big impact, because the EU tends to be, let's just say, much more strict than compared to the USA. Now, to give you an example, it's only a few weeks ago, maybe 2 months ago, they tried to pass a bill in the USA, where OpenAI and Sam Altman were saying we should have access to take all the data we want, and nobody should care where it comes from. We shouldn't have to pay for it. We don't care about copyright. We don't care about infringement. We don't care. We should be able to take all the data in the world. But it failed in the Senate. The bill didn't go through. It was 10 years of do whatever you like with my data from anywhere, but it failed. Okay? So keep an idea that even though the AI companies live and breathe from data, that is, without it, they can't survive. But they shouldn't be allowed to take that data from us and do whatever they like. Okay? Now, the other one, there is one other thing, there's what's called the IFR. And again, this one is a little bit more, maybe I've not mentioned it in here, forgive me. But there is basically a regulation from basically the government, the White House, which is that if we're building these models and training these models with our data, we should have an ability to not allow them to be exported outside. Okay. Now, those of you who are very deep data scientists in AI models would know that you don't need access to the model to copy it. Yeah, you can actually copy the model without actually stealing the model. Now, the reason I say that is my co-founder Asim and I earlier we were chatting about watermarking, and I'll explain watermarking in some of the technology we use. So the idea is that I could take an inference from an AI model and take the data out, and once I got the data, I can't trace it back to where it came from. Right? Now, if I took the data out of the model and I added some kind of watermark post-inference, I may be able to say this content I'll put on YouTube or somewhere, I can at least say the watermark came from there, and then if the watermark comes from there, I can then tie that to the model. But if I can copy the model through mechanisms where I'm taking it somewhere else, and there's no watermarking built into the model, then I can use it, and I've stolen the model and there's no way of knowing. But if there's a watermark built into the model, then whatever the model generates as an inference, as an output, right, you can trace it back to the model, and then using lineage provenance back to the data, back to the raw data. Okay, so these are all these things. So coming back to here, obviously what I'm trying to do here is break it down to each of those frameworks and regulations on which area they're focused on and why. So you can see here the ISO, International Standard providing requirements for establishing, implementing continual improvements of the AI management system. And that word AI management system is actually core to that particular framework. Okay, the EU first comprehensive legal regulatory framework for AI, and again, it's a horizontal, it's covering the whole EU and every aspect of AI. Okay, so that's the most important part. And as I said, it's there for you. I made sure I put a lot of information on the deck, so if you just want to do a quick review, hopefully will we share the deck with everybody? Will they have access to this? Yeah. So all the information will be there. Okay. This is really what it all comes down to. All of these regulations, all of these frameworks, all come down to these basically governing and sort of core values and principles, right? Which is AI governance framework, risk management, bias and fairness controls, human oversight, explainability, auditability, all of these privacy. So let me give you an example of all of this in a summarized way. Okay, so what we want is we number one, when we interact with AI, we want to know exactly if it is AI or not, or where AI was in that journey. Okay, that's something we want to know, because from a auditability and accountability, if something happens, so if you're an insurance company and you need to pay out something, you want to know how did you come to that decision. Or if an insurance company, you have an accident, says, sorry, you cannot have the money, and somehow their AI, and to give an example, think of a bias within AI. Right? The bias is, and this has already been proven, the bias is that the AI has a bias, and now forgive me for this, it says if you're a black person, you're more likely to commit a crime. Can you imagine? Right? That's not fair. Right? But if the data says so, then the data says so, but then you've got to make sure you deal with that bias. Yeah, so things like that. So as I said, explainability. Okay, this is a very, very hard subject. So when an AI model, an inference, says something, gives an output, especially like a neural network, how can you explain how did it come to that decision, right? Now, I can definitely say, even if I ask the question, no matter how many years or decades you've been working in AI, and I've been working in AI since '86, I studied a master's degree in artificial neural networks in 1993, right? Even though I wrote in C, the programming language, all of it, and gradient descent, and all the other aspects of it, right down to the last piece of code, once you've trained a model and you've got the hidden layers, you don't know how it's doing what it's doing. I can't work out. But there are algorithms that help you explain why it came to that decision. Okay, so it's really, really important that we, I think as humans, don't just build a child that becomes God. So I'll conclude with examples of this. So we've gone from very little use of AI to having enough compute and data to build a real AI. We are seeing not huge leaps in AI. Believe me, neural networks have existed, at least I know, in 1993. So it's taken this long. As far as LLMs, there's only been a few little breakout moments with transformers. But outside of that, there's actually not a lot gone on. It's the same old thing. Right? It's just more data and more compute. So NVIDIA continues to build more chips that are faster and quicker and so forth, because when you're training models, that's where it takes the greatest amount of time. So what I want to conclude with on that front and all of these areas is that all this regulation and guidance is purely because it's a black box. We have no idea, right? But we are accelerating towards a future with AI, right? And we're doing it at such a pace that, as I said, and then we hit super intelligence. Okay. Now, to give you an example of, all the countries from America to China to DeepSeek and China to whatever are all fighting now for AI supremacy. Forget nuclear bombs. AI is the way is going to be the changer. If you think of Mark Zuckerberg at Meta, he's offering $100 million to the right people to join his company. I said to Asim, I'll just go work for him and I'll give you half the money. I don't have to spend 3 years building kernel. I'll just take 50 million in my pocket and go. And he said, no. So he said, not yet. It's free. Yeah, easy money. Okay, so let's come back to the core values. Okay, so lack of provenance and traceability. All right, we just don't know. It's a black box. Do we really have the tools to trace what has happened? And what I mean by that is, if you think of the life cycle training stage, you start with raw data, you turn it into data sets, vector databases, you then take that data, then you run experiments to train the model. Eventually, one of the experiments hits the level of accuracy, precision, F1 score, all the metrics you have around AI models. And when you're happy, you say, great, I'll deploy the model. But you've done all of that, and then the model runs as some kind of autonomous being. You ask it questions and it just gives you lots of answers. But you need to track all of that. So what we do at Kernel is we've built a technology we call trustworthy AI, where what we do is we fingerprint every stage. And what we mean by fingerprint is, and I'll keep it a very simple way. So you get the raw data and you create a hash. Simple. It's easy, SHA-256, not very expensive. I get a hash. I've got the data set that I created, classification, everything else taken care of. I hash that, done 2 hashes. I train the model. When I'm training the model, as I train the model with the data set, I have a log file, and the data set and the model and the log file all have unique identifiers, so you can tie the 3 together. So we hash the log file. After the experiment is finished, we hash all the weights. right? So you're capturing snapshots of everything at every stage, and ultimately, if you're familiar with, as an example, Merkle trees, where we take all the hashes and we turn them to one hash. Okay? Now, that one hash is the ultimate fingerprint, right? So now, when you, and again, this is what in our technology we call the control plane orchestration layer. If you use our orchestration layer, those hashes have been put on the blockchain, right? So that's the immutable ledger part of it, where, or a database, we don't really care, to be fair, but we use blockchain because we, as a company, started in Web3, but now we're applying our control plane onto AI. So all the ideas of provenance and traceability, remember provenance is about tracing to something to its origin, authenticity. Okay, weak governance and oversight. So as I said, we talked about biases. The model could, you don't know, it could be biased in some other way, with the wrong data for training. One of the things in research, and obviously I read a lot of research papers, is there's a view that a model which has all the weights you think set and they don't change, when the prompts are being prompted, the model will automatically start changing the model weights, right? So that means even though you think you've done your training, the models are actually changing underneath with every prompt. Now that is really worrying, because even we right now, if we get to the level, I think in our technology at Kernel, with trustworthy AI, we will have to build something with every prompt to record the state of the model at every prompt, or delta, see what changed, right? So it's quite intricate. So just give an example. So regulation, what we try to do with our technology is, we don't say in our technology that we are building something that is 100% any of these regulation compliant, because that is hard to do. And number one, it's hard to say we do it, because the first time something goes wrong, somebody will sue us because we said it was perfect, and then we would lose out. So we created a framework where you can create the guardrails before and after, you can apply policies, you can apply whatever you need in a very cryptographically secure way, so you can trace this back to the lineage, to and the provenance, to whatever state it may be. Okay, so that's the part of the regulation part. As I said, I don't want any of you thinking that we at Kernel implement the policies for regulation. We give you the tools to implement those for regulations and policies. So a good use case, and it's always good with an example, is that we have one company we're working with from India. They have, I think their valuation is 4.2 billion. They have IP worth 1.2 billion terabytes, whatever it may be. And they've asked us that they want to protect the data. So they're training models at the moment, but once the models are ready, they want to expose the models for people to use. So they may use the models in a free way, and they expect a watermark to be in the model and very obvious that this has come from there. But if somebody pays for use of the model, they want the watermark to be, something that's not visible. But once that inference, that data comes out, you pass it from one AI agent to the next AI agent. You want that to carry through all the way, all right? And as it carries through, the more you want it at every stage, you want to check, has the customer paid? Have they broken any IP infringement? All these things, these gates that need to be done. Okay, so it's very complex at the moment, and what I want to explain with coming back, and I'll sort of, before I sort of wrap up my session, this is what, if I was to sell you Kernel, this is basically what I'm saying, right? What we do is we provide you the tools to be able to implement governance, right? We're hoping that the idea is that we would like to make the world aware of what regulation, what frameworks, what you need to have as people, so you don't use a black box and you don't use it blindly. Okay, that's the core part of our message from Kernel point of view. Okay, so I think I'm not sure how long I've gone along, but I've exhausted myself. So if there's any questions or answers right now, or maybe later, we can take care of that. But I hope that's enough.